All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Rainbow, which normally observe it at the time of raining. So it means when the things are happening all around us, we must understand scientifically that why those things are happening. So when we need to have a better understanding of these things, we must understand the concepts behind this, and that's why we'll be focusing on the interference, diffraction, and polarization in the coming lecture. Hello, welcome to Schand Academy. I am Professor Nitin Puri, who will be delivering a lecture on interference of light today. If you want to go more in detail about it, you can see the name of the book, which is coming at the lower side of the screen, where you can go through with that book and can have detailed discussion of those topics which we are covering in the class. How many of you have heard about interference? We know when two people talk with each other also, the interference occurs. Now the point is, do we need to understand what exactly the interference of light is? Do we understand the interference of the waves is? Now we all know about light, we all know about waves. Because in the preceding classes we must have heard of the waves, we must have heard of the light. So if I ask a question to all of you, is there any similarity between the waves and the light? So let me ask the question in another way, because a lot of practical examples are there of interference of light, interference of waves, because a wave pattern or a light pattern, these two things remain in the matter. So as we know, the dual nature of matter, which consists of the wave nature as well as the particle nature too. So it means when we are talking of these two things, it means few phenomena say that it is behaving like a wave, few phenomena say that it is behaving like a particle. Now we'll be focusing on the practical applications of the interference, diffraction, and polarization. So we all have, as I've started with this interference, the interference occurs in all the things which we are observing day to day life. We have seen the light peeping out in our room when the sun arises, and there is a hole in the door. When light comes inside the room, when room is completely black, we see a dark light coming from that spot too in the room, and we could be able to see something onto the wall or somewhere. So it means a few millimeter spot is there from where the light is coming. So it means the source of sun is a big source is there, and that light is coming from that particular small area into that particular room. You see, so but have we observed it, that is there any reason for coming out of, is there any phenomenon which is happening? Yes, the phenomena are happening. We are just trying to learn all these things, that the things which we are observing in the practical life, do they have scientific understanding of those things or not? Only this is not. We can have the refractive index of the liquids, we could be able to know with the help of the interference. So it means refractive index, we know it. We could be able to see the rainbow, which normally observe it at the time of raining. So it means when the things are happening all around us, we must understand scientifically that why those things are happening. So when we need to have a better understanding of these things, we must understand the concepts behind this, and that's why we'll be focusing on the interference, diffraction, and polarization in the coming lecture. So let me start it with the interference, as it is clear from its name, as I said it earlier also. When the wave is propagating Now let me say wave propagates. Suppose you see this, if you see this, if I just say it and I just make it in that way, a wave is propagating in a positive x direction. This is only a single wave. There is no interference in it. Till the time some other wave which is having the same frequency and they are having the initial constant phase difference, if they are superimposed with each other, surely there will be an interference between the two. Now, what does it mean? What does it mean when I said that the frequency should remain same and they should have a constant initial phase difference? Now, I hope everybody knows about the phase. Everybody knows about the amplitude. So it means when we say amplitude, it means they should have the intensity plays an important role too. But right now I'm saying that amplitude is there. So where those waves are superimposing with each other at few places will be having the constructive interference, and at some places where their amplitude is not matching with each other, at that particular point of time they will be having a destructive interference too. So it means we'll be having a constant pattern will be observed onto the screen, right? What does it mean? It means if the one wave is propagating in one direction, another wave of having the same amplitude is, suppose it is like this, if it is propagating like this, or the another wave which is propagating in that wave, these two waves, now I have made three waves, the another wave which is having a phase, another phase of having a difference of 180 degree, if it is superimposed with that wave, will not be able to observe those particular constructive and destructive interference. Now, when we say constructive and destructive interference, it means at some point of time we are getting the maximum intensity, and when we say destructive interference, it means we are not getting that particular light onto those particular points. It means we are getting systematic pattern. Now, we can ask those questions that what are the important, characteristics, or what are the important points which we need to take care for observing the interference. Now, let me ask in that way. When I said the phase, what does it mean? Because when I'm saying that wave is propagating, so when wave is propagating, I said it, the particles are associated with it. So what does it mean? What does it mean when I'm saying these particles are there? Because as I said it is a dual nature. It is considered as a particle, it is considered as a wave too. Now, when I'm saying that wave is going in a positive x direction, does not mean that particle is moving. No, particle is not moving. Particles are at their same place. They are at the different places. Now, when I'm saying phase, it means, it is propagating on its axis, and we need to know what is its value at a particular instant of time. It means that instantaneous value at a particular instant of time is normally considered as the phase, right? So it means particle is not moving from one place to another place. It is the energy which is getting transferred from one particle to another, to another, to another, to another, and then energy is getting propagated from one part to another part. So this is what exactly we need to understand it. And when these are superimposed with each other, surely we'll getting the different type of interferences happening, and we'll be getting constructive and destructive interferences, right? As I said it, that if we need to observe the constant interference or sustained interference, I must say specifically, there are a few conditions which should be satisfied before observing this pattern. Now, what is that? As I said it, number one point, that what is number one? Number one, I said it, that the two interfering sources, whatsoever we are having it, they should have the same frequency, number one. Now, they should have the constant initial phase difference, right? These are the 2 points which we talked about it, to observe a constructive and destructive interference on a regular interval of time. Now, as you can see, so as I'm coming on to the point again, the phenomenon of formation of maximum intensity at some points and a minimum intensity at some other point, when two or more waves of equal frequency have constant phase difference and they arrive at a point simultaneously, superimposed with each other, is known as interference. So this is what exactly we could be able to cover it, as we said it in terms of constructive and destructive interference. Now, as you can see onto the screen, we had mentioned it, these two waves, when they are in the phase, will have a constructive interference, and they are practically perfectly in phase. You can see this one, and they have equal amplitude A, and this will lead to a combined amplitude A is equal to 2A, right? And then when the two waves are out of the phase and will give destructive interference, and they are 180 degree out of phase, which you can see onto the figure B, which is onto the screen, and of equal amplitude A, this will lead to a combined amplitude, which is the difference of A and A is equal to 0. So it means when they are in the same phase, the amplitude is adding up and it is becoming 2A, which is observed from figure A. And then when you see the figure B, where they are out of phase, having a phase difference of 180 degree, the amplitude becomes 0, right? So, okay, let me have another presentation of dark or bright constructive or destructive interferences. You can see this at the point where waves are getting, coming in the same phase, and constructive interference onto the screen is being observed. When they are in the destructive interference, we will be able to observe the dark spot over there, and when bright we are talking, it means we will be able to have the bright spot over there. So it means different type of constructive and destructive interferences will be observed. Let's take a small break. After that, once we come after the break, we'll be understanding it by which method we could be able to observe the refractive index of the liquid with the help of different applications in terms of the Newton rings, or by other methods. Can we do it with the help of the interference? Yes, we can do it, which we'll be studying after the break.
हाय, आई एम मनीषा सिंगला। मैं इनऑर्गेनिक के कुछ कॉन्सेप्ट्स जैसे कि बॉन्डिंग है, आयनिक, कोवलेंट, एटॉमिक स्ट्रक्चर है, उनके प्रिंसिपल्स हैं, थियोरीज हैं, उनको थोड़ा इजी मैनर में एस चांद एकेडमी में बताऊंगी। तो अगर आप मेरे साथ पढ़ना चाहते हैं तो सब्सक्राइब ज़रूर कीजिए।
Okay, welcome back to S Chance Academy. Before the break, we had come to the question that Newton rings are the example of the interference, and we could be able to know the refractive index of the liquid with the help of Newton rings experiment. This Newton rings experiment is very important, and in the first year labs, we all perform this type of experiment. Now, how do we do that? And is there a specific reason for observing the Newton rings? Before coming on to this part, we must understand first that what are the minimum conditions required for sustained interference of the light waves. Now, it means when we are saying that any two waves which are superimposed with each other will produce the interference, no. There are few conditions for observing the sustained interference of the light waves. Now, what are those? And when we understand all these 4 points, 5 points, we will be able to understand, yes, we will be able to observe the Newton rings, and we will be able to understand how can we calculate the refractive index of the liquid, any of the liquids. Now, first point, which I said it in the previous sections also, will come on to that particular part, that the two interfering waves must be having the same frequency, and they must be observed from the coherent sources. Now, what do you mean by these coherent sources? As I talked about it, suppose there is a light source, right? And we are having the two sources, which are the two sources coming from that particular one source, right? When we are saying that coherent sources, these two sources should be derived from the one source. And those 2 point sources, as you can see this one, if I say this a source S, and if I say the two sources S1 and S2, so you see this S is a single source we are talking of, Now the point is, I did not mention anything about it, that what type of source we are talking of. Either it may be monochromatic. Monochromatic, I hope everybody understands it, which consists of a single wavelength. It may be dichromatic, it may be polychromatic, whatsoever. Is there a specific reason for putting any of the source? And then the two sources, S1 and S2, should be derived from that source, which are considered to be coherent sources. And in that little bit point, I'll say, when the light is coming from source S and reaching to S1 and S2, which are considered to be two slits and considered to be the two sources, the Huygens principle play an important role here. What does it say? That every point will work as a point source. Light is coming from here, reaching to the S1 and S2. From this S1 and S2, every point in S1, that particular slit, in S2, they are working as a single slit. Single slit in every point is working as a single light source. And then when wave is propagating from S1 and S2, there is a interference is happening between the two, and at the screen, if this is a screen, we'll be observing different type of constructive and destructive interference onto the screen. Now you see, right now we only come to know that there should be a source, light source, and that source should produce two sources, and these two sources are producing the interference onto the screen. Now, they should be coherent. Now the point is, if they are, and our next point is, that they should be having the constant phase. Initial constant phase difference should also be maintained. So this is the another condition for observing the sustained interference of the light waves. Now the second point, it is there, interfering waves should have a constant and equal amplitude. This is another condition which is required. Now the third point, if we are, now the question is, if we are not having it, if we are not having the constant amplitude, we will not be able to observe the constructive and destructive interference on a regular interval of time. So this is the second condition required for observing the pattern. The third one is, the two interfering waves must be propagated along the same line. This is also important. If they are not moving in the one direction, we are not going to observe the pattern or sustainable pattern of interference if they are going in opposite directions. So this is, it means the third point is there, that they should be propagating in one line, right? If we are talking of a positive x direction, it is fine. If they are in the other directions, they should be in the same, right? Otherwise, we will not be able to observe the pattern. So what the three conditions we could be able to know now. The fourth one is the separation between the two sources by which that particular source is producing those two sources. They should be very narrow. They should be very close to each other. It means, as you can see onto the screen, the S1 and S2 sources should be very close to each other. Now let me put an example. Everybody is having the tube light in our home, right? And then if the tube light is wrapped up with the black paper, right? And then we make the two holes in those tube light. So the light will be coming from those two sources. Those two sources are made with a single light, that is a tube light. And then if we put something in front of the tube light, will we observe any type of diffraction pattern? This is the first question, because this is a practical example of understanding the interference. The interference can be observed with any of the light, which I said it in the first condition, that for obtaining the sustained interference pattern, the light source should be having of specific wavelength, or any wavelength will produce the interference pattern. It means you all can do the experiment at our home also. You just wrap it with the black paper, put two holes which are very close to each other, and put something in front of that light. You see whether you observe anything or not. So, but I tell you that we will not be able to observe anything, even if those two sources or two holes which you kept it at very small distance also, because the light source is not a monochromatic source. Monochromatic, which should consist of a single wavelength. Single wavelength, if you ask the examples, we have an example of sodium light source. Sodium light is considered to be a monochromatic light. Now, what do you mean by monochromatic? As I said it, but the another question arises, sodium light consists of the two wavelengths normally. This is consists of 5893 and 5896 angstrom. Now, the question arises always in our mind that if we are talking of sodium light as a monochromatic light source, but it consists of two wavelengths, why it is considered to be a monochromatic? It is considered to be a monochromatic because those two wavelengths, 5893 and 5896 angstrom, are 589. I said it 5890 and 5896. I'm sorry if I said it 5890 and 5896 are the two wavelengths which are observed for sodium light source. But the difference of those two wavelengths is of 6 angstrom only, which is very small. So it means that cannot be observed from the naked eye. We need to use some spectrometer to observe those particular difference of the wavelength. So that's why sodium light is considered to be a monochromatic, even if it consists of the two wavelengths. Answer is because the wavelength difference between the two wavelengths is very small. So now it means now we are concluding one thing, that from any of the sources, if from one source two sources are being made, those two sources be coherent only when the condition is satisfied that from the source by which those two sources are produced should be monochromatic. It means now we'll come on to the third part, fourth part is this one is the separation between the two sources must be small or as small as possible. If we don't do so, we'll not be able to observe the diffraction pattern, and there will be, because I said it by Huygens principle, every point will work as a point source, will not be able to observe the constructive and destructive interference onto the screen. Now the next point, the two sources must be narrow too. The two sources, it means, now let me come to little bit of diffraction so that we can have an understanding of it little bit. When we say diffraction, we just not in detail about we'll go, but when we say diffraction, the bending of light around the edges of a corner is known as diffraction, right? So it means we'll not go right now in detail about diffraction, just try to have an understanding of it, that when the slit is very small, when the light is coming onto it, the light is getting bent at the edges of the corner of this one, and we observe the diffraction pattern. Let's not go in detail about diffraction, but the point is that the sources which we are talking in terms of observing the interference pattern is that the two sources must be as small as possible, and these two sources should be narrow too. And the last point which is important to observe the sustained interference is that if the interference waves are polarized, they must be in the same state of polarization. Otherwise, we will not be able to observe the interference pattern onto the screen. Now, when we say light polarized, or when we say the normal light, it means all light consists of, because all different characteristic properties. So tube light, which is scattered in all the directions, we're having so many wavelengths. But when we talk of the monochromatic light, which consists of a single wavelength, when we talk of a polarized light, it means vibrations are only in one direction. Because if we say polarized light or unpolarized light, the difference is that unpolarized light means vibrations are happening at all the directions and in all the ways. But when we say polarized one, it is a specific direction by which those particular vibrations are happening. So this is normally we do it with the help of understanding. So there's 5 points which we could be able to understand this time for observing the interference pattern. These 5 points, and then I hope you must have understood it for observing the sustained interference pattern. What are the important points required? So this is the end of part of it. If you want to go more in detail about the topics, I can recommend the textbook of engineering physics by Professor Avdhanulu, which is coming onto the screen, and you can go in detail about these subjects with this book. I hope you must have enjoyed it. Please like, share, and subscribe.